Now we'll take a look at what happens if we have a compound object. So for example, let's say we have a bunch of rods, okay, and they're all attached in kind of like some kind of star pattern. Okay, so each rod has a length L and a mass M. Okay, and we want to find the moment of inertia of the entire system. Okay, so again, in your book, you would have the formula that the moment of inertia for a rod is m over 12 L squared. In the last video, we showed how to use the parallel axis theorem to show that if instead of rotating about its center, if we want to go around a parallel axis, so let's say we're going to rotate around this point, so this is actually coming out of the page, okay? This is actually the same exact thing as the example in the last video. The only difference is now we're moving a distance L over 2, and the axis is, so that part's the same, but the axis, we've just kind of rotated the system. But it's still the same thing. So this moment of inertia we saw was m over 3 L squared. So we'll just use that so we don't have to redo that calculation. If you don't remember how we got that, just go back and watch the last video. Okay? So now to calculate the new moment of inertia I, it's just as simple as adding up all 5 of those. So we just have 5 times m over 3 L squared. So that's the moment of inertia for this system. Now if we want to add something else to it, you know, say we wanted to do something like I don't know, attach a disk to the back of this, right? And so like these, we'll have all of these sitting on top of a disk, and this disk has a radius r, and so there's a certain moment of inertia associated with the disk. I think that's also actually mr squared over 3. I'm not positive on that, but we'll just call it for now. We'll say that it's just I disk. And so if we look at this whole system, then the new moment of inertia is just 5m over 3 L squared plus the moment of inertia of the disk. So we can add together the moments of inertia of compound particles just like we could add together the moment of inertia of point particles. And so in the next lecture, I'm actually going to do something that I haven't seen anywhere else, but that I think is pretty interesting, and it's useful to complicate moments of to calculate the moment of inertia of even more complicated objects.